Class, today you study the last chapter on LCA3. After studying main thing on LCA3, today you study the stack. This is the final chapter on LCA3. You know, when you study stack, you should understand what it is. I can tell you that this is a very important data structure. In future, you will encounter this in many applications. In the chapter, we will describe three things. The first, interrupt-driven I/O. In the chapter 2, you study, but not a lot. And when we go to the chapter, we can solve some problem you didn't study in the chapter 2, input-output. The second one you study is the way to evaluate arithmetic expressions. And the last one you study the way to use the stack for data type conversion. And with this session, I give you some example. I ask you to write the full program from these things. Generally, we say stack. That is a LIFO. That infers our storage structure. That means the first thing you put in is the last thing you take out, or the last thing you put in is the first thing you take out. So when you want to work with a structure, you can understand the data you put in. At that time, we have the operation put. And the data you take out, you use pop operation. So over here with the picture, you see a data element or data item you put into the stack, and over here you want to take out. And when you look at the picture, you see you have the top of the stack, and the data element is on the top of the stack over here. And over here we see the bottom of stack over here. And you know, when you study stack, firstly you can understand a physical structure with the picture. This is the stack of coins of quarter, and you know you have some stacks for stack. Firstly, you see initial stack. You know, with the stack, you have the initial stack, and you don't have any coin in the stack. And over here, after we put one coin to the stack, so we see the picture. And you know, after 3 more pushes, so we have 1, 2, 3, 4 coins over here. And this is the last coin you put in. And after 1 pop, so we have only 3 coins in the stack. And with the hardware implementation, you see the picture like this. And you know, with this data item to move between register, and you have 4 stacks. The first initial stack, and you see over here you can use a variable, and when it's yes, that means it's empty first to put in. And if we put one data item in the stack, so we have this item. Of course, when we have only one item, so it's on the top of the stack, so we see it's here. At that time we say empty, no, because you have one item in the stack. And after 3 more pushes, so you have 1, 2, 3, and 4. So this is the push item. So over here, now we have the last item, so it's on the top of the stack. At that time, the variable empty, no, to say now it's not empty, and we can pop. Okay, so over here now, after 2 pops, so we have only 2 data elements in the stack. And normally we use a variable is on top to point to the top of stack. with the software implementation, over here now you say initial state for the stack. With the LC3 we use the register ASIC. It store top of stack. Over here the stack is empty, so top is point to this memory location. And when we push one data item in the stack, and over here now the top is point to this location, storing the value you just put in. So we say after one push, so we have the top of stack. That means the register ASIC storing the value. This is the address of this location, 3FFF, the address of this location. And after 3 more pushes, over here now, the first data item, now over here it becomes the last item. And when you want to get out, you have to take out all of this item firstly. And over here now the value tail is on the top of the stack, so it is pointed to by toss, that means top of stack like this. And over here now ASIC is storing the address of toss, so we have tail value, the location store the value tail is at 3FFC, the address of this location. And after 2 pops, so what happened? Because over here the value in this location we shall be pop, that means we read it out, so over here it still exists in the stack. And after 2 pops, so we just change the value for toss, that means the stack pointer ASIC. So now after 2 pops, ASIC stores the value 3FFE. This is the address of this location, storing the value 31 over here. So as just mentioned, there are 2 basic operations when you want to work with stack. The first, push. The next part, when you want to push a data item to the stack. So firstly, you have to decrement the stack pointer. So over here we do add, extension. Extension. For example, over here now you have the bottom of stack, and if you want to push a data item to the stack, so firstly you need to decrease, you need to decrement the value for the stack pointer ASIC. So over here now firstly we decrease the value for the stack pointer ASIC. And over here you want to push in, so we do store with the base register ASIC. Now the value you want to put in, we call it a data item. Now this is stored in the register A0, so we put it to the location pointed to by ASIC, the base plus the offset 0 over here. And the same thing for perp. Over here, if you want to read out, if you want to take out value from the stack, over here, now firstly, we read out from the base register at offset 0. Over here, now you have the base, the address of the location storing the data item you want to read out. Okay, and we read this out and we assign it to A0. Over here, we sum the A0 is storing the value you want, and then you need to increase, you need to increment the value for the stack pointer ASIC.